oxygens right here. How many, Nicole, up front? 4, and each one makes a contribution of how much? Look on your periodic table here. Oh, you can't see that far, okay. 16.0, and your textbook, you carry it with you, there's a periodic table right in front. So we have 4 oxygens. Be careful. 4 and an O, it's not 40 of something, the zeros and the so forth. Yeah, Andrew?
On the sulfur, if you round it, it's like 32.1.
Yeah, let's do that. Excellent point. Good, let's do that. Good point. We're going to take it to the nearest 1. So then we're going to add this all together. And what are we getting? Does someone have, what are we getting here?
132.1.
132.1. And what are your units?
Grams per mole.
Grams per mole. Okay, you've got to get a formula weight first. I don't know how many times I've seen my best students can go through a whole problem like this really well. They screw up on the formula weight, and you're going to miss it, no matter how much other stuff you know. Okay, so let's take it first to moles. 39.6 grams. And that's what's going to dictate our 6. Okay, now I want to go to moles. What do I do? If I got grams and I need moles, what do I do, Brittany?
Divide by the weight.
Okay, let's do that, and let's just do it in one set of parentheses. So grams and grams cancel. Moles come around on the top. We don't even have to get an answer there. We can, though. Sarah, do you have an answer for this one?
Not yet.
Okay, let's go 3/6.
299.
With 299, and the
Well,
units
it's
are
2.997, so it would be 2.300.
Yeah.
3.00 if we round there. And the units are what, Sarah?
Moles.
Moles. Okay, now, if you do stop there and write it down, and you round at that point, you're going to get a slightly different answer than the rest of us that just keep it rolling. So I'm going to keep it rolling up here, and some of you keep it rolling. Okay, now I've got moles, so the next thing it wants to know up here is molecules. Molecules. So we need to move one more place over. Russell, what do I do now?
I don't know.
Okay, you're here.
Oh,
I'm not going to let you off the hook that easy. You're here.
you multiply by 6.02 times 10 to the 23rd.
Okay. What are my units, Russell?
Molecules.
Tell me more.
Over
Per.
moles.
Per
1 mole.
per 1 mole. Okay, moles came around on the top, moles are on the bottom. So if we want a checkpoint right here, then let's look at how many molecules we have right here. Meredith, do you have it?
Molecules.
Molecules. What would the answer be when we get the second part? 1.8. 1.81 times 10 to the 23rd. Molecules of ammonium sulfate. Okay? Now, let me add the zinger on. How many atoms of hydrogen could we get out of this? How many atoms of hydrogen? But for every molecule, Bruce. And I've got a load of molecules. Okay, so what I'm asking is, now what you need to be thinking, because that problem's not going to make any sense if you don't think, what this means is if you could take this, you could rip it totally apart. Every time you have one molecule of this, we will get 8 hydrogen atoms. Okay, now we're not talking about its diatomic here because that'd be a molecule of hydrogen. We want to talk about an atom of hydrogen. And so, if I want to know how many atoms of hydrogen I could get, what you have to think, rip it apart. And just as Bruce said, we're going to get 8 atoms of hydrogen for every one molecule of that original ammonium sulfate. Molecules cancel, that's going to tell us atoms of hydrogen. Emily, read that question for me, the way it is. Listen carefully how it is in the book, because it'll mess with your mind. Go for it. It's, what number is it, 811, or 211, excuse me. What was the original wording of it?
Calculate the number of hydrogen atoms in 39.6 grams of ammonium sulfate.
End of story. Did you all catch that? It jumped right to the chase. Okay, what have I done for you? If you got grams of it, you got to find out ultimately how many molecules of that you have, because it's not until you get molecules of that you can think about ripping apart how many atoms of it would you get. And so I led you by the hand here. The book does not lead you by the hand. So we had to go on here. We had grams of the molecule. Then we got moles of the molecule. Moles of the compound, I should say compound, excuse me. Grams to moles of the compound. Then we got molecules of the compound. Then I could think about how many hydrogen atoms could that produce. Okay, team, I don't want hydrogen atoms, I want oxygen atoms. What would be the difference? Multiply by 4. Good, Nikki, I heard your voice first. The only change would be is if you're going out after oxygens, then you multiply your answer by 4. And if you're going out after nitrogen, you'd multiply by what? 2. If you were going after sulfur, 1. It's the same thing. It's the same thing. But I think if you'll visualize ripping it apart, that's going to help you answer one of these. So, again, I repeat myself a lot. I've learned. My children never hear 10% of what I say, and you probably don't either. Okay, we did this together. I led you by the hand. Okay, what you need to do is later come back to this problem, go back through it with your notes. Then, for the big time, blank piece of paper, take it from your book, where you're not led step by step through it. You got to decide, I'm going to do this and this and this first before I ever multiply by 8.